Good morning, Year 10. Just going to keep moving on with Unit 5 on graphs. Going to move on to something brand new today. We've done parallel lines before, but perpendicular lines is brand new. We haven't really considered what the word perpendicular means yet. So parallel and perpendicular lines, and to be able to understand the rules for the gradients of parallel and perpendicular lines. Now, by lines, I mean y is equal to mx plus c. Those types of lines that we've drawn previously. So we're going to consider two lines with two different equations, okay? Because I'm using two lines, I have to use the gradient is m1 and the y-intercept is c1, and the other one, the gradient is m2 and the y-intercept is c2. But we've got y is equal to m1x plus c1, and y is equal to m2x plus c2 for some gradients m1 and m2 and some y-intercepts c1 and c2. Now, you need to know two facts. First one is what happens if the lines are parallel, okay? So this is a fact you should already know. So the lines are parallel if the gradients are equal, okay? If gradients are equal, and the shortest way I can write that is, in other words, m1 equals m2. And if you get that, you'll just get two lines which look like this, okay? And depending on, that's obviously a positive gradient, but lines which never meet. So that's what you should know already. But new for today, and a lot harder, is what happens if lines are perpendicular. Okay. So firstly, perpendicular lines look like the following. So if I had a line there, a line which is perpendicular to that would be this one, where there's a right angle. Okay, that is an example of two perpendicular lines. Now, there's not really a fancy word for this apart from just the formula. Okay, so if the product of their gradients is -1, in other words, word product means times, so if I times their gradients, the answer would be -1. That would be the rule for two lines which are perpendicular. And you need to memorize that. So parallel, that's true. Perpendicular, that's true. Right, let's consider some examples. So we're going to find the gradient of a line perpendicular to a line of gradient -2. So I want the gradient of a line which is perpendicular to a line of gradient -2. Now, gradient of -2 would be a line like this going down. And one which was perpendicular to it would look like this, going up with a positive gradient. And I need to use this rule. So m1 times m2 is equal to -1. I've got one of the gradients, which is -2. So -2 times something, gradient m, needs to be -1. -2 times something, and you could just use tram lines, divide by -2. Well, you might be able to do this in your head, and that would be a gradient of a half, or 0.5. I always prefer the fraction rather than the decimal for gradients, which kind of makes sense, doesn't it? It's a little bit shallower, and it's a positive gradient, so that does make sense. Right, what about a line of gradient 1/3? We want something perpendicular to a line of gradient 1/3. So 1/3 would be a positive shallow line like this. Perpendicular would be like this. And again, we need to memorize this rule. The gradients, when you times them together, the answer is -1. So 1/3 times something needs to be -1. And to find out that something, you divide by 1/3. And if you did that, you got a gradient of -3. And again, you can always check this on a calculator, by the way. If I took the gradient -3 and I times it by 1/3, the answer's got to be -1, which is what it is. So you can check your answers on a calculator as well. Right, couple more. This time we want to be perpendicular to a line with equation y is equal to 3 minus x. So this one's a lot harder because I didn't give you the gradient directly. So what would be the gradient of this line? It would be -1, or -1/1. Okay, so you effectively want to find something perpendicular to a line with gradient -1. So -1, if you bother to sketch this out, would be perfect diagonal but going in this direction, and you want the gradient going in the opposite direction like that. In other words, the gradient of -1 times m needs to be -1. So you pretty much do this in your head, but go through the steps again. Divide by -1, divide by -1 to give you a gradient of 1, which makes sense. The perfect diagonal going in the opposite direction. And then the last one is find the gradient of a line perpendicular to a line with equation 2x plus 3y is equal to 7. Again, I do not give you the gradient directly. You have to work it out. But this isn't ready yet. You have to make it look like y is equal to mx plus c. So you can do that by subtracting 2x. And then you can do that by dividing by 3. Like so. And then what would the gradient of this line be based on that? There's enough information written down for you to work out the gradient of this line. It's -2/3. And you want the gradient of the line perpendicular to it. So you want -2/3 times something to give you -1, and then you divide by -2/3 to get 3/2. Again, prefer the fraction rather than 1.5. Let's just check that one. So 3/2 times this gradient -2/3. That's got to be -1 if we've done this right. Yes, it is. Okay. So that's pretty much using this this new property, which was if something's perpendicular, the gradients when you times them you get -1. The key thing for today. Problem is things are going to get a little bit harder. So EG number 2, giving you 4 coordinates, and you have to decide whether AB is parallel, perpendicular, or has no relationship to the line PQ. So the line A to B, is it parallel, perpendicular, or has no relationship to PQ? And the only way you can get marks for this is if you consider the gradients. So the gradient of AB, gradient of AB. Right, let's draw a quick sketch. Doesn't have to be accurate at all. -2, 5. Say that's -2, say that's 5. So there, that's A. B, -1, 1. That's -1, say that's 1. There. That's the line A to B. How do you work out the gradient of any line like that? Rise over run. Okay, the rise, it's actually going down, so it's -4. The run, it's going 1 across, so 1. So the gradient is rise over run, which is -4 over 1, which is -4. That is the gradient of AB. Let's have a look at gradient of the other line. PQ. We have quick sketch. 1, 3, just say 1's there, 3's there. That's P. Q is 5, 4. 5 there, 4 there. Q, and that's the line. And we want to work out the gradient of that line, which again is rise over run. So that triangle there, the run is 4 across, and the rise is going up, so it's 1 up. To give you a gradient of 1 over 4. And now there's enough information to decide whether it's parallel, perpendicular, or has no relationship to PQ. So parallel means gradients are equal to each other. -4 is definitely not equal to 1/4. Perpendicular is if I times these together, the answer would be -1. Let's see what happens. So let's try 4 or -4 times 1/4. See what that answer is. Again, some of you know this without a calculator, but you would get a calculator in an exam, so you may as well use it. The answer is -1. The only number which now means these lines are perpendicular. Okay, so therefore AB and PQ are perpendicular to one another. Now, some of you might be thinking, well, if I drew that on the same sketch, i.e. on the same axes, you could have probably said they were perpendicular straight away. But the problem is they don't accept even a sketch which is drawn to scale. The only way you can do this is via the gradients. So any other method would get 0 marks in an exam. So you have to refer to the gradients. Right, last question and the most difficult is find the equation of the straight line perpendicular to y is equal to 3x minus 2 that also passes through the point 3, 1. Right, I'm going to highlight some keywords. An equation we need to find, that's what our answer is going to look like. Perpendicular, straight line 3x minus 2, that's going to pass through 3, 1. Right. Now when I'm asked to find the equation of any straight line, like I was doing a couple of lessons ago with inequalities and finding the actual equation in the line, I separate it to 3 different steps, okay? And the steps are point on the line, gradient of the line, and then the formula y is equal to mx plus c. So I'm going to follow those steps, but I'm just going to draw a very quick sketch just to show what's going on with this. So we have an x-axis and a y-axis. We have a straight line, y is equal to 3x minus 2. So that would be, very quickly, going through minus 2, and it'd have a gradient of 3 over 1, 3 as 1 across 3 up, 1 across 3 up, 1 across 3 up. So pretty steep line like this. And we have to find some other line which is perpendicular to this, so going at a perfect right angle, but it also passes 3, 1. 3, 1, let's just say, is around about there. So you've got a line which is perfectly perpendicular at a right angle, but then passes through 3, 1. So there's only one line that makes sense, which is this one. And that's the thing they're actually asking you to work out. Okay. Now again, the problem is, in an exam I wouldn't be given graph paper to draw this perfectly, so I couldn't do it from this. This is just showing you exactly what you need to do, or what this question looks like on a graph. So you have to do this algebraically though in a real thing, using those 3 steps I just mentioned, which is a point on the line. Now the best point we normally want is the y-intercept. The problem is I have no idea what the y-intercept is because this is just a sketch. But the only point I guarantee is on the line is the point 3, 1, because they tell me it passes through it. So I have to use the point 3, 1 at some point. Right, the second thing now is the gradient. Now normally when you see the word gradient you think, right, rise over run, easy. But again, I don't know enough information to work out rise over runs. I only know 1 point on the entire line. The ones above in EG number 2, I knew 2 points. Rise over run was easy. But the thing I do know is it's perpendicular to this. And if you look at our EG number 1, how do you work out a line which is perpendicular to y is equal to 3x minus 2? Well, the gradient of this line is 3. The gradient of my line is, I don't have a clue, so I'll call it m. And they need to times together to give you -1, which gives this gradient as -1/3. Okay? And that's it, that's how you work out the gradient. So the last thing then is to do the formula. And the formula is y is equal to mx plus c. And normally I just replace the letter m and I replace the letter c, but I don't know plus c. I only know m. So how can you work out what the plus c is without using a sketch? And the answer is you use this point. You substitute 3, 1 in. Replace every single x value with 3 and every single y value with 1 to give you 1 equals -1/3, 3 plus c. Okay, to simplify that, 1 is equal to -1/3 times 3. On a calculator would give you -1 plus c. And if you worked out plus c by itself, it would be 2. So finally, y is equal to -1/3 x plus 2 is the perfect line which is perpendicular to 3x minus 2 and passes through 3, 1. Very difficult question, probably one of the hardest questions we've done all year. Okay, the exam tip for this is pretty straightforward. So use your calculator to check to see if the gradients times together to give you -1, and that's pretty much it. Okay, so use your calculator to check that m1 times m2 is equal to -1, I guess, for perpendicular lines. Now the questions I'd like you to try today find them. Okay, we'll just go with exercise 3. So exercise 3 only, and we'll go, that's on page 331. And yeah, any questions about that, rejoin the Teams meeting, please.